Okay, class, behind this I have a reflection, a combination of two reflections in particular, and we're going to talk about the result of this and about its magnitude. So you'll notice over here in black that this flag A, B, C, D, E, has been reflected over this line. It has become A prime, B prime, C prime, D prime, and E prime. Note right away that the reflection causes the orientation to change. Okay? Reflects it over. That being said, I also take a look at some distances here. This length from B to B prime. I'm not sure what that is, but what we're going to do is we're going to call that length A. In class, we talked about how reflections have to preserve angle measure and length. It's a rigid transformation, so it doesn't change the shape any. So reflections preserve both of those. So if you reflect this over this line, this length here must also be equal to A, little a. Okay? Then the second thing we did is we reflected this flag over a second line. These two lines are parallel to each other. I'm going to indicate that too by putting these zeros on the bottom. We have parallel lines. Okay? The second reflection must also preserve angle measure and length. So I'm going to mark that with another distance here. We're going to call that little b. So I'm going to mark this distance to the line as little b. And that same distance from b double prime to the line has to be b. Okay? Now you'll note that this image, A, B, C, D, E, is the same orientation as A double prime, B double prime, C double prime, D double prime, E double prime. And that shape looks like I picked it up and slid this over. So that transformation is something we call a translation. And a translation is a rigid transformation. Now what I want to point out to you are some interesting scales that occur here, some scale factors that occur, and some interesting magnitudes. First of all, this distance between the two parallel lines. Although I don't have any numbers up here, I do know that the length from the line to B prime and the length from B prime to this line is a combination of both this A and the B that I wrote down. So the length in between these is little a plus little b. Now the interesting thing is the distance that this is translated from here to its double prime image is related to this. Let's take a quick look here. To go all the way from this B to B double prime, I would have to travel this length, plus this length, plus this length, plus this length, which would have to be A plus B plus B. I'm going to rewrite this a little bit differently. 2A plus 2B, or 2 times A plus B. That means that the translation magnitude is actually twice the distance between the two parallel lines. So we have two big conclusions here. One, a reflection over two parallel lines, reflect once over one line, then reflect over the other, results in a translation, and that translation's magnitude is equal to the distance, twice the distance between the two parallel lines.